All right, so this is 3, 5 limits at infinity. So infinity is our in behavior. It is not a number, but it is an in behavior. And so when we take a limit to infinity of this function, it actually levels off to 3. And then if I take a limit to negative infinity, it also levels off to 3. This is our limit notation of those things, but really it has to do with the powers of our functions. So I need you to write this out. A horizontal asymptote is when we take a limit to negative infinity and a limit to infinity. It's both. On this one, we have this function of 2x squared plus 4x minus 6 over 3x squared plus 2x minus 16. And so all we really care about is these parts, okay? That's our in behavior model. And so if I have a limit as x approaches infinity of this function, I'm really only looking at the higher powers. And what do we notice about the higher powers? They're the what? They're the same. And so we look at its what? Coefficients. And so that levels off to have a limit at 2/3. And this one's well behaved because now I have a limit as x approaches negative infinity of this function. It's also going to be what? 2/3. So when I have a function of like x squared over x cubed, where is my higher power? On the bottom. So when the bottom wins, what does it go to? It goes to 0. So if I take a limit as x approaches infinity or negative infinity, it goes to 0. And then let's say we have, a 2x squared over, no, that's the same thing, 5x squared. If we have that, they are the same powers. So then what do we look at? We look at the coefficients. And so that one would be what? 2/5. All right. But if I have my higher power up top, so let's say I have a 2x cubed over a 5x squared, where's my higher power now? Up top. And so now I actually need to worry about it going to infinity or negative infinity. And in this case, it'd be infinity cubed, which is positive infinity times 2. And then it'd be over this, which would be squared. And so that's still positive. So this one actually goes to what? Positive infinity. All right. That one would not have a horizontal asymptote. So these ones would have a horizontal asymptote at y equals 0, y equals 2/5. And this one would be nothing because who won? The top one. Let's kind of put that into practice. So now this first one, I have a limit as x approaches infinity of 5 minus 2 over x squared. And so when I kind of like substitute in infinity, I'd have negative 2 over what? Really big. And so if I have a number over really big, that goes to what? 0. And so now I'd have 5 minus 0, which would be what? 5. And so that limit to infinity would just be 5. All right, let's look at the next one. So now I have a limit as x approaches infinity of 2x minus 1 over x plus 1. Again, I'm looking at this in behavior model. I'm really looking at this 2x over x part. And so what do we notice about my powers? They're the samesies. And so now we look at what? The coefficients, which are 2. 2 over 1, which is 2. Very good. All right. So this one, we have a limit to infinity of 2x plus 5 over 3x squared plus 1. Where's my higher power? In the bottom. So what does it go to? 0. All right, let's look at the next one. So now I have a limit as x approaches infinity of 2x squared plus 5 over 3x squared plus 1. So where's my higher power? They're the samesies. So what do we look at? The coefficients. So what do we get? 2/3. Very good. All right, let's look at this one. So now I have a limit as x approaches infinity of 2x cubed plus 5 over 3x squared plus 1. Where's my higher power? Up top. So what's it going to go to? It's got two choices now. It's either going to go to what? Positive infinity or negative infinity. And so when we do this, we substitute in infinity. Is this going to be positive or negative up top? Positive. What's it going to be on the bottom? Positive. So it's going to go to what? Positive infinity. I want to do another one. So now we're going to do a limit as x approaches negative infinity of this same function. We're going to call it 2x cubed plus 5 over 3x squared plus 1. And so on this one, sorry, that's positive infinity again. Negative infinity, goose. All right, and so now when we substitute in negative infinity, again, where's my higher power? They're the top. And so it's going to go to infinity or negative infinity. However, when we substitute negative infinity, what's this one going to be up top? It's going to be negative. This one on the bottom is going to be what? Positive, because it got squared. And so this actually goes to what? Negative infinity. So now let's look at this one. So now we have a limit as x approaches infinity of 3x minus 2 over the square root of 2x squared plus 1. All right, so where's my higher power?
Wait, they're samesies.
They're the samesies. They're the same. Because this is really to a power of what? 1, and this is a squared square rooted, so those are inverse operations of one another. So guess what? They are the same power. So what do we look at?
Coefficients.
The coefficients. And so what do we get?
3 over 1.
3 over square root 2. All right. So we get 3 over square root 2. So now we're going to have limit as x approaches negative infinity of this same function. On this one, again, where's my higher power? They're the same. However, we actually need to worry about the sign a little bit here. So when we substitute in negative infinity, what is it going to be up top?
Negative.
It's going to be a negative. What's it going to be on the bottom? A positive. So on this one going to negative infinity, it's the same coefficients, except now the top is what? Negative 3 over square root 2. And so now I actually have horizontal asymptotes at both y equals 3 over square root 2 and y equals negative 3 over square root 2. I actually have 2 horizontal asymptotes. So here's the little function. Again, a horizontal asymptote, you can cross in whatever is deemed the middle. However, you cannot touch towards the end behavior of it. But that's how this function would look. All right, so this first one, I have a limit as x approaches infinity of sine x. Limit as x approaches infinity of sine x. So let's go back to our pre-calc days. What is sine bounded by? What is the range of sine? Negative 1 to 1. Okay, if you think about your sinusoidal curve, it's bounded by negative 1 to 1. And so if I take a limit to infinity, it's actually an end behavior. And so what's it doing as I go towards the end? It's going to toggle back and forth between what? Negative 1 and 1. And so does my limit exist? No, this does not exist because why? It oscillates. Let's look at this next one. So now we have the end behavior. So I have a limit as x approaches infinity of sine x over x. Now, you should recognize that guy. However, it's going to infinity now. But what did we know the limit as x approaches 0 of sine x over x was?
1.
That was 1. However, this is an end behavior. This is the way I'm going to kind of treat this one. What is sine x going to be in between? Negative 1 to 1. And so up top in my numerator, I have negative 1 to 1. And my denominator, I'm going to have infinity, which is going to be really what? Big. So who won? The bottom one. And so when the bottom wins, what does it go to? It goes to 0. So that's the way I would think about that one. However, if you wanted to look at the bookwork, this is what you do. Sine is bounded between what? Negative 1 to 1. Then, because you wanted to, you just divide everything by x. And then if I take a limit to infinity, negative 1 over infinity would be 0. 1 over infinity would also be 0. Therefore, the limit of sine x over x is also what? 0. By the little squeeze theorem. All right. So what are all the horizontal asymptotes for the graph y equals 5 plus 2 to the power of x over 1 minus 2 to the power of x? So what's a horizontal asymptote?
Limit as x approaches negative infinity and limit as x.
Both of them, exactly. So I need to take a limit as x approaches positive infinity, and I need to take a limit as x approaches negative infinity. Guess what students only did?
Positive.
They only did the positive infinity one. All right, but you need both, and that's what we're going to cover right now. So if I go to positive infinity, I don't really need this 5 and this 1 because this is the rate that it's growing. Okay, it's not a polynomial, it's exponential. However, it's growing at the same base, so these are still base 2. And so it's really like 2 over negative 2, which is what? Negative 1. And so when I take a limit to infinity of that one, I get -1. And so now we'd have y equals -1. And a lot of students just answered A. However, they forgot to do the limit to -infinity. And so this reminds me of my childhood. And so now we'd have what? I'm going to just substitute in -infinity. So now I'd have 5 plus 2 to the -infinity over 1 minus 2 to the -infinity. But what happens here?
Well, he has to go to 10 above.
He goes to the basement. However, he doesn't go to this far basement. It's like a basement up top too. And so now it would end up being like 5 plus 1 over 2 to the infinity. And then 1 minus 1 over 2 to the infinity. What does 1 over 2 to the infinity do? It goes to 0 because the bottom got really big and I got a number up top. And so that goes to 0. So now I have 5 plus 0 over what? 1 minus 0. And so my limit as x approaches -infinity would be what? 5. And so I have y equals -1 and y equals 5.
E.
So page 205, 1 through 6, 19 or 13 through 29 odd, and 35 through 38. On 1 through 6, I would do your horizontal asymptotes, and then I would actually find your y-intercept. So substitute in 0 and figure out where they're shifted. That would be my suggestion on that.